Hello, welcome to another briefing. I'm back to calling these briefings. Also, I have a new sound setup. I'm using my microphone now. I hope this really helps out with all the little sound glitches and annoying keyboard sudden error sounds and stuff, because that was happening a lot in my briefings before this one, and I'm really starting to want to make the sound cleaner because I want these briefings to be more enjoyable. I want you all to be able to really absorb all the science and all the meteorology behind them and what I'm getting to with them. So with that out of the way, I'm also going to be looking a lot more at current weather maps and satellite data, all the current data we have available that actually assesses the real atmosphere and tells us what's going on and why. And then I'm going to eventually at the end of the video touch a little bit on computer model guidance, but computer model guidance is computer model guidance. It's the weather models doing their best given the current atmospheric conditions to project what might happen in the so-called virtual atmosphere in the future. But we don't know what's going to happen in the atmosphere in the future because it's not what's happening now. But if we have a good solid understanding of what's happening now, we'll be able to better assess what could happen in the future. So with that out of the way, let's start out with the satellite image from this morning right now. And we're gonna pick up what a few things, right? We're gonna go back in time a bit. Actually, we're going back as far back as we can go here, which is the 18th. See, okay, this is 10 p.m. on Tuesday night, and so this is where we had the pretty cold weather system out of the north that is affecting the Bay Area and California right now. It's when it had just started to come down. It actually started Monday night, Tuesday morning, but we can't go that far back anymore. But we had quite a bit of serious heavy downpours in the Bay Area on Tuesday with some hail involved, including pea-sized hail at my home in southern Marin County. I do have a few photos. Unfortunately, not the really good ones are still on my phone, but I have this one. I have one that I can show here. So here we go. There's just a little idea for you. We got another dumping of hail many hours after this that was even more significant, but you can really see those little pea-sized hail pellets, pieces of hail, really. And so I'm going to explain a little bit about why that happened. Is we had a lot of cold air aloft and not warm air at the surface, but much milder air. And so that made for a lot of positive buoyancy, which means that the air parcels rising from the surface were able to stay warmer than their environment all the way up to very high levels of the troposphere. And that initiated a lot of thunderstorm-like cumulonimbus clouds. In fact, actual thunderstorms, because we did have a lot of thunder and lightning, and we had small hail. We had very severe, not severe technically by that category, but we had very strong thunderstorms. And this developed even as cold air was coming down in from the north, because you did have some divergence at the surface, which looking at that alone, you would think, oh, that would prevent any kind of thunderstorms. It helps mitigate that, but we still had a lot of divergence aloft, the air spreading out aloft with these little vorticity maximums, as we call them, these little pockets of spinning air associated with an upper level low pressure that was present over the area at the time. And what that divergence aloft does is it removes mass from the column from above. And so in order for the atmosphere to compensate that, there's convergence at the surface. So even if you were to look just at the surface pattern alone, you would see divergence from high pressure, surface high that was starting to come in. However, look at the bigger picture, look further up, and you see a lot of divergence, a lot associated with this upper low, and that can sort of override the divergence at the surface. And these aren't like they're not warm front type storms where you have a lot of what we call isentropic lift at the surface, where you're going to have that warm rising air all the way up, or significantly up, the troposphere, and you have long organized bands of thunderstorms. This is a lot more scattered but very strong storms when you get caught in one of these pockets of divergence, of vorticity aloft, as you can notice here. These pieces of energy here. See all those like scattered but strong storms. And then this is as we went through the day on Wednesday. Look at all that fresh snow. I'm just gonna go ahead and update that because it's going to do that anyways. But now I can go back here and look at all that fresh snow. Pretty far down on the Sierra Nevada mountain range. I mean, this is the Grapevine area. You're looking at snow at about 4,000 feet. San Gorgonio Mountains, some pretty low snow. San Jacinto Mountains as well in the Coachella Valley, Palm Springs region. And you see these continued pockets of vorticity aloft, giving those pop-up pretty heavy storms. And we actually did have some low snow in the Bay Area as well. I don't have the video saved, unfortunately, but we can actually go ahead and pull it up. I have an image. Okay, this is this morning, but I don't want to get too much into the weeds, but let me go ahead and show you here. So this is just a still image from Mount Tamalpais yesterday morning, just a few miles from where I live. Elevation 2,400 feet, about 800 meters. And you can see here snow accumulated on some of these rocks, some of the shrubbery here. There was a little bit of snow that fell there last night. This is pretty much the first time in 3 years since it has snowed up on Mount Tamalpais. We finally got a weather system with air that was cold enough to allow that to happen. So, I'm going to just go ahead and move on because I have a lot of stuff to talk about. But we're going to move on here. So you see, and then we had another upper level disturbance, what we call a shortwave trough. A little ripple in the jet stream brought down yet another cold front. This was yesterday night. More of a steady. So there's a cold front and there's a warm front. I should specify. Here's your cold front down here. Here's your warm front up here. Now the warm front really gives us that, and this wasn't warm by any means. It was just milder than the air around it. There's sort of a mild tongue here ahead of the system, and that actually caused the snow levels to rise a little bit ahead of this system. Still pretty low snow levels, around 3,000 feet, but up from 2,500 to 2,000 in some areas, even mixing down to 1,500 by some reports in certain areas. So that snow level went up a little bit again because we had a little bit of warm air come in, but then we had the colder air come in again right behind that, and now we have lowering snow levels again. Still not quite as low as yesterday morning, but that could happen for some areas, and we'll take a look at the temperature profiles on the sounding observations pretty soon. But you do see that cold front come through, and then notice how it's a lot drier behind it because you don't have the large scale lift enforcing from that warm sector anymore. But you do have these little scattered pockets of vorticity aloft, which do bring those scattered popcorn-like but quite strong showers at convective showers at times, and sometimes there's hail embedded with those, as I showed on that image, which doesn't really do justice because I have some images of my balcony just completely covered in hail, which is a very rare sight. I don't think I had even seen that in many years. So this is a very exciting weather week here today, or this week. And then let's go ahead and look at the reanalysis of pressure hikes. Now, this is going to be a little confusing for most people, but it gives you kind of an idea of what's going on here with what I was talking about. Here's the big parent upper low to all of this that I was talking about. And then here is, see, all these little pieces. See, there's a little shortwave trough here. There's another one roughly over here. Everywhere you see these little ripples in the atmosphere, the pieces of energy that are moving through. But basically, this is going back to 4 p.m. Monday when this really cold air was just starting to move down. We had a pretty good front Monday night that pushed through. And then as we go in 4 a.m. and then 10 a.m. Tuesday, you can see the next system, kind of tell here, the next little impulse of energy right here. This is another cold front. Even though it was pretty cold already, it got even colder with that next cold front. Came through on Tuesday. And then here's 10 p.m. on Tuesday night. Even colder air. That cold air continues to come down because you can see this upper low sends one piece of energy, and then here's another one diving right down, even colder, straight from the north. This is really cold air diving down with these systems, which is why the snow level got so low. Because then you go into, here we're at 4 a.m. and then 10 a.m. yesterday, and you notice how that really cold air was coming down, and that's what caused that snow level to get so low. That's what caused that snow over Mount Tamalpais, and that comes down. And then this is 10 a.m. yesterday, and then here is, this is actually what's going on. This was 10 p.m. last night, and then this is technically going into guidance because this is from last night, but this is for today. See, another piece of energy diving down. That's why we're having rain showers in the Bay Area this morning. I'll go ahead and show the radar next, but you see these pieces of cold air just one after the other coming down. This is what we call an open storm door pattern, where you have a ridge of high pressure offshore, and you have another one, kind of a minor one, over the east coast. And that, in between those, you have this big trough that allows this cold air to come down, and it also allows storms that are riding the jet stream to come right down into the west coast, into California, into the Intermountain West, which is a very different pattern than we had in January, which was more of a blocking pattern. And unfortunately, we might actually have that develop again, because into next week it's a bit hard, it's a bit uncertain to tell. But we can actually go way back in time here, and here we go. This isn't as far as we can go on another page, but this gives you an idea. This is going back to February 5th, before this whole barrage of storms started, and we had very much of a blocking pattern in place. Big ridge out here. This was sending all the storms up north into the Pacific Northwest, into Canada in some cases, way north. And this was keeping even the Pacific Northwest very dry for winter time, since I think they had a week or two straight without rain, which is pretty rare, because everything was getting sent north and then down into the East Coast. They were just getting blasted with cold plunge after cold plunge, snow. All the winter-like weather was over the East Coast. And so you can see very different pattern than what we have now. This pattern has pretty much completely flipped by now, which is why we're having so much rain. Now, going ahead, showing the radar for this morning, there are those showers I was talking about with that next disturbance passing through. We're still going to have a lot of these scattered popcorn-like storms that can be a lot, they can be a lot more, they're scattered, but they can be strong at times, and this can dump hail depending on how much instability and how much vorticity you have, as I was talking about earlier. Go ahead, let's look at the TAM camera now. We had a little bit of a warm advection with that warm front I was talking about, even though it's not warm for most of our standards. It was milder than it had been, and so that is unfortunately causing more rain. As you can see on the camera, there's some liquid precipitation at the top of Mount Tam right now. Might still switch over to snow if we get enough cold air to mix down again, but we'll see. Station plots, you can see this is where Mount Tam is. It's just a tad bit too warm, 34 degrees Fahrenheit. It can still snow at this temperature, mind you, but it has to be usually associated with heavier bands of precipitation that are able to mix down colder air from aloft, because it can be well below freezing aloft, and you can get strong enough rain that it kind of drags some of that cold air down to the surface, and that's how you can get snow even if it's 34 or even 37. But the conditions aren't quite there yet. It's raining, but it's not raining very hard, so it's not really dragging down a lot of cold air. So it's still borderline sort of a rain-snow mix in places like Mount Tam right now, but this is very chilly for Mount Tam. This is a lot colder than it tends to get with most of our storms. Most of our storms, Tam is well into the 40s, and the snow level is way up at 5,000 feet, even higher. A lot of storms we had over Christmas and New Year were very warm type storms in that matter. We might actually get another warm storm as it comes in. We go into Sunday roughly. I'll show that on the computer model guidance. So that's giving you an idea of the temperatures. Now next here we have a sounding, which is a very important tool used in meteorology, and this is actually what feeds a lot of our computer models. I'm just going to go ahead and show you. Here is, I mean, it's a lot. I understand it's very technical if you're not into meteorology, but what I can show you here, which should be easy to understand, is here's the 0 Celsius line right here. Now these are slanted because you want to be able to follow the path of air parcels. If I get into it, it's just gonna, the video is gonna be too long. But you can see that 0 Celsius line. You can see this is the red is the environmental temperature, and you see it intersects that at the 900 millibar level. This is pretty close to the surface. That's roughly 3,000 feet. Okay, so there's a 3,000 foot freezing line here. Usually this freezing line with most storms is way up here, way up at 5,000 feet or such, as I was just mentioning. So you can tell much lower freezing levels, not quite as low as it got yesterday morning. Not to say that could still maybe happen, but that's what we're observing. Something else that's interesting to note here, I don't think there's really going to be much severe weather threat for the Bay Area with this, but you can see this wind shear. See, there's winds out of the southeast here near the surface, and winds out of the west not too far up. That is what we call vertical wind shear. And that is, if there was more instability here, if there were other conditions that were coming together, that's the kind of stuff that you look at for rotating thunderstorms. I don't think we're gonna have much of a threat. Don't worry about it. But because this is just one factor, other stuff has to come together as well. But this is interesting to notice. We have quite a bit of shear on the Oakland sounding this morning. Just tells you a lot of different useful information. When you get used to interpreting these, it's really helpful. It took me a while to get my bearings with these, but it tells you a lot of useful information about the atmosphere, which is really good to have. I'm just gonna bear with me. I hope this doesn't get boring, but I'm gonna try to show you the main purpose we use to, which is to follow an air parcel. And so before it reaches its condensation level, it's following the dry adiabat line here. And then when it reaches its condensation level, when it intersects where the dew point was at the surface here, then it's going to start rising moist adiabatically. It's going to cool more slowly because you're getting latent heat release from the condensation that's occurring. And so this is roughly the path that this air parcel will follow. And you can see this is not very well drawn, but when the parcel eventually, with enough lift, gets to a point where it's warmer than its environment, this is what we call positive CAPE, convective available potential energy, which means you have a pretty significant area where the parcel is warmer than its environment, so it's going to continue to rise, and that's going to give what we call buoyancy, which allows a favorable environment for more thunderstorm type kind of clouds to develop. So that's what we're seeing here on this sounding. This isn't nearly as much CAPE as we see over, say, the Central Plains in spring when we have severe weather outbreaks, but just something to notice, another tool we use to get a picture of what's going on with the atmosphere, and just kind of put all the pieces together and kind of do a post-mortem of the storm system, as my professor would say. So here we go. This is just a text version of the sounding, and this is what we use a lot to look at how low is the snow gonna get. So for instance, 925 millibars, that's usually about 2,500 feet. I did the calculations. 691 meters converts to about 2,200 feet for this morning. And you can see temperature 2 Celsius. So it's just a tad bit above freezing. That's about 36 Fahrenheit. Dew point 1. So even if you condense, if you get to saturation point with this air parcel at 2,500 feet, it's still not going to be freezing. That's why it's just a little too warm to get snow down to Mount Tam, but maybe this will change in the next couple hours before the daytime heating really kicks in. We shall see. I won't get too technical with this now, but this is just kind of another way of giving you an idea of inside forecasters' heads of what we're looking at when we're trying to forecast snow levels. And then here's our computer model guidance. This is the fancy graphics that most people like to show, but they do this without showing the actual weather conditions, which I think is really important if you really want to get an understanding of what's happening with the atmosphere. But as we put this guidance into motion here, you see that weather system coming through today. There's that next front. Still pretty low snow levels because you're still in the cold sector of the jet stream here. See these blue lines? That indicates colder air. That's still in place coming down from the north. So that's going to give you plenty of cold air for your low snow. And then here that kind of ejects. You have some cold air behind it. You're going to have some really cold nights in the Bay Area the next couple nights on the back side of that system. And then here's the next weather system. But notice something about this one. See how there's a lot more there are a lot more red lines here compared to blue lines. And see how the general flow direction, I mean, I haven't really talked a lot about how wind goes in the upper atmosphere, but it basically goes counterclockwise around low pressure in the northern hemisphere. Now I won't get into the reasons why, but that's pulling in warmer air. That's a southwest flow here ahead of this system. That's pulling in some milder air, so you're going to have higher snow levels. This is going to be what we call a warm storm. Snow levels maybe 5,000, maybe 6,000 feet, way higher than we have now. This is what we had a lot of the during the holidays. This kind of setup where you get a lot of warm air. You got a subtropical tap as this rain comes in, and the core of the colder air, you check the 540 line for really the barrier in between the colder air and the warmer air, and that gets pushed further north. So any moisture that we have here, it's pretty warm, in a pretty warm air mass. So that's what I was talking about earlier in terms of cold storms versus warm storms. And unfortunately, it's looking like we're getting a pretty warm storm after this, which isn't great news for ski resorts and our snowpack, but it's what it is. And then it actually looks like it dries out a bit, maybe a little more ridging, maybe a weak system in early March, but this is way into what we call fantasy land on the computer models. You can't really trust computer model guidance, especially when you're getting further out. I know this is a very long video. I hope this wasn't too boring for people. I just think it's very fascinating to really understand everything that's going on with the atmosphere and why. And I'll probably get better at explaining these things with time as well. So thank you for bearing with me. Well, that's all I have for today. I hope you're able to get something out of this. I hope this was helpful, and I'll see you next time.